Hi, I'm Jeremy Gates, Managing Director of Gaia Construction. We specialise in renovations and extensions in Bayside and the surrounding suburbs of Melbourne. What is a passive house? A passive house is designed to have a stable indoor temperature between 20 and 25 degrees Celsius all year round, but needs very little energy to heat or cool. Passive houses are renowned for being comfortable and healthy to live in and cheap to run. Sound too good to be true? The Passive House Institute was founded in Germany in 1996, and Europeans have been successfully building passive houses for many years. In Australia, interest in passive houses has been growing, and the number of passive houses being built here is snowballing. There are rigorous standards that must be met before a house can be certified as a passive house. The 5 basic principles are glazing, airtightness, insulation, thermal bridging, and the heat recovery ventilation system, called HRV. All 5 principles must be correctly incorporated into the building, otherwise the building will not perform to its full potential. Although passive house principles are most commonly applied to new buildings, they can also be adapted to renovations. In a passive house, windows provide light and free heating in the winter. By ensuring that the size of the windows is appropriate to each orientation, solar radiation can heat the home during the winter months and not let too much heat in during the summer. Also, the windows must be airtight. Windows are traditionally the weakest link in the building envelope, allowing warm, cool air to enter through the home. In colder climates, the windows in passive houses are generally triple glazed. In Australia, low emissivity double glazed windows can be used. In order to ensure that the heat doesn't enter the home through the window frame, frames must be thermally broken or non-metal, timber or UPVC. And there cannot be any gaps around the windows. There are no leaky windows in a passive house. Airtightness. A passive house must be airtight. There are 2 airtight layers, an internal layer and an external layer. The internal layer is to stop warm, cool air leaking in or out of the home. The exterior layer is the waterproof layer and is to stop water coming in. Both layers must be continuous with no breaks or holes. This requires meticulous attention to detail by the builder and the designer. Making the building airtight means there's no more drafts. Insulation. The floor, walls and roof of the house must all be insulated with no gaps or breaks. The floor must have a minimum level insulation of R4 and the walls and roof a minimum of R6. There is no rule on the type of insulation you can and cannot use. Polystyrene and earthwall, for example. However, some insulation types perform better than others, with the better performing products meaning that the walls can be thinner compared to the less efficient products. The insulation not only needs to meet minimum level, it also needs to be continuous, so penetrations through the insulation must be kept to an absolutely minimum and sealed up properly. Thermal bridges are the area of a building where energy, heat or cool, can transfer directly from the inside of the building to the outside of the building, and vice versa. In a passive house, all thermal bridges must be eliminated. This can be done by the use of insulated construction materials or by incorporating thermal breaks to prevent the direct transfer of energy. For example, aluminium window frames can act as thermal bridges, so can only be used in a passive house if they are thermally broken. Heat Recovery Ventilation System, the HRV. In a passive house, the HRV is the lungs of the house. This ventilation system is essential because the house is completely airtight. The HRV runs 24 hours a day and provides a constant supply of fresh air into the house and extracts stale air from the house whilst keeping the indoor temperature between 20 and 25 degrees Celsius. It's like opening your windows without losing the heat or cool from inside the house. This is because the HRV systems can recover up to 90% of the heat cool from the outgoing air and transfer it to the incoming air. Apart from avoiding the dilemma of fresh air versus saving electricity on heating and cooling by keeping the windows closed, a HRV is perfect for people who suffer from asthma, as most of the pollens in the outside can be filtered out within the system. It also lowers the risk of condensation, meaning a healthier indoor environment. HRVs use no more electricity and make no more noise than a fridge. A small price to pay for constant fresh air inside and a stable, comfortable indoor temperature all year round. Dispelling some myths about passive house. We've heard some misinformation about passive houses, perhaps you have too, so we'd like to address some of the myths. 1. Passive houses only work in Germany or cold climates. This is false. A passive house will provide a stable and healthy indoor environment whether you live in a cold or warm climate. Myth number 2. You can't open your windows in a passive house. This is false. Of course you can open your windows. While your windows are open, the HRV system will not be able to maintain a stable indoor temperature. But when you shut your windows, the indoor temperature will stabilise again and the passive house will continue to function as normal. Myth number 3. You can't have a wood, gas or coal fire in a passive house. It's likely that you will not be able to have an open fireplace, but you can install fires that have real flame effect, e.g. bioethanol fires. Myth number 4. When you go on holiday, you have to turn the HRV system off so the house gets very stuffy. This is false. If you go on holiday, you can leave the HRV system running. It will use no more electricity than your fridge. Myth number 5. Passive houses are very expensive to build. This is not necessarily true. If you are planning to build a good quality energy efficient home, lifting it to a passive house standard will not cost significantly more. The glazing will be slightly more expensive. Creating the airtight layers adds marginally to the labour and there will be extra insulation. However, these will not add significantly to the build cost. Removing the thermal bridges can be achieved through careful design, and doing this will not cost much more than a standard well-built home. The HRV system can actually be cheaper than a heating and cooling system. Why build a passive house? The top reasons to build a passive house or incorporate passive house principles into your renovation are: save money. Are you sick of budget-busting electricity bills? Because passive houses only require a small amount of electricity to run, they are cheap to run. No need to fear your electricity bills or worry about increasing electricity prices. This means it will be possible to calculate how much electricity will be needed to heat and cool a passive house for its entire lifespan, a calculation that can be taken to the bank when requesting a loan. Number 2. Fresh filtered air without opening your windows and losing heat or cool. This is an attractive proposition for most, if not everyone, but it is particularly crucial for those suffering from asthma or other respiratory issues where clean air is essential. Number 3. Reduce your carbon footprint. Less energy used means fewer carbon emissions generated. Passive houses allow for energy savings of up to 90% compared with typical existing buildings. If you're interested in investigating the possibility of building a new passive house or incorporating passive house principles into your renovation, call us. Building a passive house requires careful planning and execution, and it's essential that you involve the appropriate certified professionals. I'm a certified passive house tradesman and passionate about the benefits that passive houses have to offer. Give me a call. I would love to have a chat with you about your passive house.